Hey guys, it's Mrs. D here, and I'm going to do a couple of the Hess's Law problems for you that we've done in class today. You'll also see on our Schoology page, I went through and showed how to do the problems for all of them, but I just want to explain a few things now so that you fully understand what's going on. So let's take a look at number 3 on the homework page I gave you today because I had a few questions for number 3. So first off, sorry, let me get my pen going here. Okay, so the first thing is we want to look at our main equation here. So we're looking for N2O, NO2, and 3 moles of NO. And so let's look at our first equation. And so what can we get from that first equation from our actual data? So we come up here and we're like, oh, well, there's the NO. So we can get that, but it's on the product side and 2 NOs on the reactant side. So we're going to need to flip this. So we're going to take our first equation and we're going to go N2 plus O2, and we're going to flip that bad boy to 2NO. Now I know your inclination is definitely going to be to make this a 3NO, but what you'll find is there's NO, nitrous oxide, in another problem down here. So we're going to be able to accompany that. So since we've flipped it, we need to change our delta H to positive 181 kilojoules per mole. Okay, and then we're going to go to our next part. So our next part, hey, there's the N2O, there's the dinitrogen monoxide. And so, but there's 2, and so we need to half this. We're going to multiply everything by 1/2. So therefore we get N2 0 dinitrogen monoxide, and we're going to get just 1 mole of nitrogen gas and 1/2 of a mole of oxygen gas. So that means we also have to multiply our delta H by 1/2. And when we do that, we get 163 times 1/2 is 81.5. So we're going to get, it's still a negative 81.5 kilojoules per mole. The reason why it's still a negative is because we did not have to flip our equation. Okay, the last one, we're going to get, hey, there's our other NO, and there's also our NO2. So in order to get our NO2 on the other side of the equation, we're going to have to flip it. So we're going to have NO2, and we're going to flip and have nitrous oxide plus 1/2 oxygen. And since we had to flip it, we're going to make our delta H positive 57 kilojoules per mole. So let's go through here and find out what we have and what we need to get rid of. So we've got our NO2 from our equation, and we've got our NO2 on our reactant side. Now on our product side, we need 3 NO, and there's 2 here and 1 more here. So now we just have to get rid of the rest. So notice on our products, we have N2, we have reactants over here. Then we have 1/2 plus 1/2 equals 1 whole oxygen on our product side, and we have 1 whole oxygen on our reactant side as well. So we're good. So we're just going to add these delta H's together, and we're going to get 181 minus 81.5 plus 57, and we will get 156.5. So our final enthalpy here, 156, sorry guys, this is really messy, 0.5, and that's kilojoules per mole. All right, so let's take a look at number 4. Determine the value of the enthalpy change for this reaction. It's a combustion reaction. And so if you're thinking of entropy at all, let's just look at it in terms of entropy here, just for practice. So if you look, we've got 1 mole. So look at the gases. We've got 1 mole of gas plus 5 moles of gas. We have 6 moles of gases on our reactant side and only 3 moles of gases on our product side. So we're actually going to have a negative entropy. So just a little review. You don't have to have that for the test that we're doing tomorrow. However, we need to get this equation written out. So let's take this first one and what pieces can we get from it? So we've got our CO2 and our O2 here. So we can work with that. And so let's just keep it going the same direction. But we do need to have 3 CO2. So we're going to multiply everything here by 3 and including multiplying our delta H by 3. So we're going to have 3C plus 3O2 yields 3CO2. And then we're going to multiply our delta H by 3. And if we multiply our delta H by 3, we get 393.5 times 3. Whoops. And we get negative 1180.5. Okay, so this next one, what parts do we need? Hey, there's our liquid water. That would be really helpful. And according to our equation, we need 4 moles of liquid water. So we're going to have to multiply by 4, and we're going to flip it. So we're going to multiply our delta H by negative 4. So we're going to do 4 times 1/2 oxygen. So that's 2 oxygen. And we're going to add 4 hydrogens, and we're going to get 4 moles of water. And if we do our delta H by 4, we'll take 286 times a negative 4. So we get negative 1144. Okay. Now, finally, the last part, we have our C3H8 gas. And we have 1 mole, and we have 1 mole. So let's just keep it at that. So we'll go C3 H8. Let's see here. C3H8 yields 3C plus 4H2. And we're just going to, sorry, that's an H2. And we're going to keep it at our delta H is 105 kilojoules. And so let's go through here and find out what we need to keep. We need to keep the C3H8. We have 5 O2, so we've got this here by 2 plus 3. And we've got 3 CO2, sorry, that's kind of messy there, and a 4 H2O. So let's see if we can cancel everything else. We have 3C on the product side here, 3C on the reactant side here, 4H2 on the reactant side, 4H2 on the product side. So we're going to add our enthalpies together. So we've got 1180.5, and that's a negative. And we're going to add that to negative 1144 and add that to 105. And we're going to get our overall enthalpy is going to be negative 2219.5, and that's kilojoules. All right, guys, so there's a couple of problems. This is Hess's law. Just take your time, and you guys can do this. All right, take care.